Okay, today we are going to learn about transfer function. Now, what do you mean by transfer function? We have already seen in the classroom that it is the ratio of output to the input, but it is not the plain output or plain input. We generally take a Laplace transform of the output, and if we take the Laplace transform of the input when all the initial conditions are assumed to be 0, then it is called as transfer function. So the transfer function is the ratio of output, that is the Laplace transform of the output to the Laplace transform of the input when all the initial conditions are assumed to be 0. So this is very important point over here which is mentioned in this paragraph. Now let's see how diagrammatically it is represented. So we have seen this diagram in the impulse response. So any system which is a LTI system is represented by h of t, y of t is the output, and x of t is the input. So now when we take the transfer function of this in time domain, it is y of t is equal to x of t convolution of h of t. However, by convolution property, y of s is equal to what? X of s multiplication of h of s. So what is h of s is equal to? H of s is equal to y of s upon x of s. So what is y of s over here is? Y of s is the output and this is the input. So the transfer function h of s is equal to y of s upon x of s. So this is what is called as a transfer function, that where you take the ratio of output divided by input. Now let's see one example, and one very important thing which I forgot to mention, that you have to write initial condition is assumed to be 0. Now let's take an example of find transfer function of d square yt upon dt square plus 3 dy of t upon dt plus 2y of t is equal to x of t. Now what happens to the transfer function? If you remember the property of differentiation of Laplace, which we have seen in the previous videos, so we will take the Laplace transform like this. It will be s square y of s minus y0 minus y prime 0 minus. This is the derivative Laplace transform of this. Now when we take the Laplace transform of this, it will be 3 s y of s minus y of 0 minus, and this will be plain 2 y of s is equal to x of s. Now since the transfer function is only valid when the initial conditions are 0, so this term will become 0, this term will become 0, and this term will become 0. So since initial conditions are 0, so it will be s square y of s plus 3s y of s plus 2y of s is equal to x of s. Okay, now when we rearrange it, it will look like this, that y of s is equal bracket में s square plus 3s plus 2 is equal to x of s. Now what is the transfer function? It is the ratio of output divided by input. So we will take it over here and this will go over there. So it will become like this. So finally the transfer function is y of s upon x of s is equal to 1 upon s square plus 3s plus 2. I hope you have understood what do you mean by transfer function. So in the next video we will be seeing the modeling of electrical system. That's it. Thank you.